Hi everyone. The topic which was given for our team is steel mill industry. Our team members are myself Harshvardhan Annamalai Muthu, Vivek Chandran, Hafiz Wakar Asmat, Vedant Anand.
From the early Stone Age to this current modern age, materials have become an integral part of the human culture, and iron and steel are the primary components of the industrially manufactured usual products that human beings use. So, to meet this requirement, steel factories are now becoming an important feature of this modern area of industrialization. So steel can be manufactured in two ways. In first, we heat the primary concentrated mixture combined with limestone and tar, and then these materials are converted into metal oxides and contaminants. After this one, these products are fed into the blast furnace at high elevated temperature, and after this one, the molten steel is formed. In second process, vanadium is extracted from the molten iron until it is converted into the steel. Because why we are using vanadium? Because any steel with a high content of vanadium is considered as a good quality of steel, and also vanadium is rich in slag, which is the best for the steel manufacturing. Coming towards raw materials in used, these are the materials that are used for the steel manufacturing, like the coal, iron sand, limestone, argon, and it is very important in any industrial sector to characterize the waste that are generated in any industry. For the steel mills, we have like the solid waste, liquid waste, and other elements. In the solid waste, we have slag, refractories, JCP sludge, scrap, dust, debris, and some other particles. For the liquid waste, and there are grease oils and other effluent products, and some variety of toxic elements, carbon monoxide, chromium, nickel, and these chemicals are very dangerous to the environment and more importantly the people's well-being. Three R's: reduce, reuse, and recycle. They play a very important role to identify the waste streams and their minimization in any industrial process. And in steel mills, we have four waste minimization opportunities that are iron bearing slag, iron ore slimes, blast furnace dust, and waste heat recovery.
Now, talking about the waste treatment methodologies, steel mill industry generates a large amount of waste, both solid and liquids, and these contribute to environmental pollution. For the production of 1 ton pig iron, 300 to 400 kilograms of slag is produced as waste. So there are more methods for treatment of this waste and also to produce a value-added product from these. There are some of the methodologies used in the steel mill industries for waste management and to produce alternate products from the waste. First one is mechanical activation. Generally, clinker is used for the production of cements, which requires a lot of thermal and electric energy, and also produces a large amount of CO2, which results to environmental pollution. So instead of this clinker, industrial waste such as fly ash and blast furnace slag is used in many countries, which requires less amount of energy and reduces CO2 emissions low. This new type of cement is called blended cement, which uses fly ash and granulated blast furnace slags. And second method is synergistic usage. This method is gaining more popularity for management of solid waste. For the production of ceramic floors and wall tiles, innovative technologies has been used from the fly ash and blast furnace from the steel industries. And third one is thermal plasma technology. This technology is considered to be the environmental friendly and is the good practice for processing of materials. This technology has a positive impact on every stage and ends up in not harming environment in any form, and it is also contributing to zero waste to make a cleaner and safer technology. And the last one is reverse osmosis application. Uh, Through IS, it is possible to make the environment have less impacts from the industry from the waste produced and save energy, raw materials, minimal usage. So, talking about the appropriate waste treatment methodologies according to the different classification of the waste, such as solids and liquids, thermal plasma technology and reverse osmosis application is found to be the promising technology for the management of waste. because of its environment friendly and producing alternate products from the waste, making safe and cleaner products. Into the effluent disposal options. One of the major components of the municipal solid waste is steel, after the metals, and it has been recycled material throughout. The waste produced by most of the steel mill industry causes health problem and potentially environmental degradation. Many of the company uses the three R policies, that is recycle, reuse and reduce. In addition, many of the company uses the policy of wealth from waste, as they use their waste to produce useful products such as cements and tiles from fly ash and furnace slags. Other than recycling, waste management is done by landfilling, developing new sites which does not include any chemical or toxic waste, and to be used in agricultural lands. By these options for disposal, these have the great advantage of um, in economic growth and a positive impact for the stability of the environment. But due to the pollutants present in the effluent, it is necessary to study the properties of such waste and opt for the better disposal options.
Technical, environmental, and economical analysis of the waste minimization options. The first one is iron bearing slag. The bearing slags are used in hydraulic industries for metallurgical use. It is also used in cement industry as sliming and amending material, which is also used in road works. It can be also used as fertilizer. Few experiments can be carried out to reduce the carbon level, and the iron can be recovered separately. The next one is iron ore slimes. Iron ore slimes are produced during the processing of iron ore. Iron ore slimes can be used in the removal of lead and mercury iron from industrial wastewater by commercially feasible technique. These slimes are biggest threat to the surrounding because it directly affects the surface degeneration, groundwater pollution, the destruction of forests. Blast furnace flue dust. Blast furnace flue dust are combination of oxides that are formed on the top of the blast furnace. These dust contain toxic substances like zinc, chromium, arsenic, etc. It can be recycled either by making it with a cold bonded briquette or by injecting it through viruses. Flotation technique can be used to recover the carbon particles. The final one is waste heat recovery. Numerous technologies were developed for waste heat recovery, and many industries also have improved the energy productivity using this technique. All these technologies are being used to not being used to its fullest extent due to the barriers like material costs and maintenances.
Hello everyone, I'll be taking over with the design of selected waste treatment. So in the mill industry, it is important to understand that the waste generated is classified into two categories. Solid wastes that generally include metal slag pretreatment, GCP sludge and refractories, whereas liquid wastes that are basically the water concentrations that are produced while making steel mills in the form of hot strip, plate and billets. Hence, it is evident that these solid wastes are to be recycled as they are vital to produce newer steel products that would require much lesser power than the originally made products in the iron ore. Hence, the design selection is based on the classifications of these two wastes. Thermal plasma technology can be applied for the process of solid waste disposal. It has a tendency to remove toxic wastes and is eco-friendly. So the design includes components such as a furnace for gasification, which is a vertical shaft used to remelt steel scrap. The amount of solid waste is then injected from the top. To bear the temperature fluctuations and corrosion, the furnace is in subject with refractories. Plasma torches are used to melt the inorganic substances present in the waste. Subsequently, coke is added along with the solid waste that has lower reactivity than the waste materials. Hence, it's consumed lesser, resulting in the municipal solid waste to quickly gasify. Another advantage of the coke bed is its space that provides slag, metals and flux to flow down vertically when the gas flows above. The coke tends to react with the entering oxygen to provide heat in larger quantities for the gasification. Further mechanism resulting in the process of purified syngas in the form of hydrogen and carbon monoxide, which is 99% effective. To treat the liquid waste from the outlet sources of hot strip mills, reverse osmosis application can be applied. So the design components include cartridge security filters, a UF unit, two-stage RO unit, and an activated carbon filter. The poor water quality is determined using the cartridge filter, where the raw water is screened using those filters and then passed to the tank. The analysis on raw water is performed using ultrafiltration, which is very reliable in removing minute substances that could have been neglected by the cartridge filters. The ACF is then used to treat the feed water of odor and for the removal of organic chemicals. The feed water is then passed through the RO two-stage pass, where water is passed through the first stage and anything that has not been treated is passed through the second stage, where the concentrated water becomes the feed water for this stage, which is then discharged as permeate water.